part of chapter 3 has to do, obviously, with consciousness, levels of consciousness, things of that nature, but we also have to talk about drugs and how drugs can interact with the brain and basically cause a variety of different perceptions and so on. So when you're taking a look at this screencast, definitely look at page 123 in Myers. There is a chart that goes through and talks about various drugs and the effect that those drugs have. Highly recommend you kind of memorize that chart. That will come in handy later on, especially when we get to the AP exam. So let's take a look here in terms of various drugs. Basically, I want to explain what we mean by the term psychoactive drugs. Our brain is protected by a layer of capillaries called the blood-brain barrier. Um, Essentially, drugs that are small enough to pass through that, then they can actually get into the brain and they can have an impact on the brain and cause various psychological functions or malfunctions within the brain. And so those we refer to as psychoactive drugs. All right, if they can basically, if they can get through the blood-brain barrier, then we refer to them as psychoactive drugs. Drugs, just a reminder, we've talked about this before, but they can be they can take one of three actions. They can either be an agonist, in which case they mimic a natural neurotransmitter, and in that case, essentially most of the time it causes more activity within the brain, more firing of neurons. It can be an antagonist, which basically means that it will kind of create a problem with neurons firing. So, in essence, it kind of prevents or slows down the firing of neurons in the brain. And then there is a set of drugs called reuptake inhibitors. And these are drugs that basically prevent that neurotransmitter from being absorbed back into the sending neuron. So all three of these can create issues. Now, one of the things about drugs, they've done a lot of studies over the years with like rats, and years ago they would take and literally put a little electrode into various parts of a rat's brain, and then they would stimulate those areas of the brain, very specific areas of the brain, to see what kind of behavior it would cause within a rat. And what they did is or what they found basically was that there were a lot of areas where the rats would continue, like when given the option of like pressing a lever or pressing a button, they could stimulate their own brain. And they did this. They found that there were a number of areas that the rat would actually increase its stimulation of its own brain, and almost every single case, either directly or indirectly, led to a release of dopamine in one particular area of the brain, and that is the nucleus accumbens. This area right here. It's down toward the very base of the forebrain, but that area, the nucleus accumbens, is kind of referred to as the reward center or pleasure center of our brain. And so what rats were doing is they were consistently rewarding themselves in that essence. So that's basically what they found with drugs, is that all or virtually all of the addictive drugs that we have today, in some way, shape, or form, increase the dopamine level within the nucleus accumbens. And so therefore, it's bringing more or less that reward center of our brain into play. Effects of drug usage. I think you guys are probably used to these two terms. These are ways that the body can react to various drugs. If a drug is used consistently or very frequently, literally the body can build up a tolerance to that drug, meaning that that basically it takes more and more of the drug to have the same impact on you. By the same token, if a person stops using a drug, at least on certain drugs, you can basically develop withdrawal symptoms. And those withdrawal symptoms can take a variety of forms, from anxiety to vomiting, diarrhea, convulsions, a variety of things that can happen. So let's take a look at some particular drugs, and we'll look at different categories and how they impact the brain. Stimulants. Stimulants stimulate or they speed up the body's processes. They increase alertness, activity. They elevate the mood. They make people feel better. They decrease fatigue. A variety of things there. Now, amphetamines in particular, they stimulate the dopamine release within the brain. Cocaine is another stimulant, and cocaine actually blocks the reuptake of dopamine, norepinephrine, and serotonin. Those three different neurotransmitters. And so, what that does is it basically leaves those chemicals within the synaptic area of various parts of the brain longer. And what it does is produce a euphoric rush that people experience. Other stimulants, such as caffeine. Caffeine, it's kind of weird because people talk about caffeine being a stimulant, and they think of, that the Mountain Dew or the coffee actually does something that it actually, I guess, directly stimulates the brain or what have you. But actually, caffeine is an antagonist. So, in essence, what it does is it blocks certain chemicals in the brain from taking effect. And by doing that, the result is by stopping the neurotransmission that it does, it allows more dopamine and more glutamate, which are basically natural stimulants within the brain. It allows them to act more frequently. So, in essence, the Mountain Dew or the coffee it's not directly stimulating the brain, but it's indirectly causing that stimulation. Nicotine, smoking cigarettes, okay, increases dopamine release, again, in the nucleus accumbens area of the brain. Basically, they've found that it has an impact on virtually the same cells that cocaine affects. And of course, both of those drugs are very addictive. People start smoking, and it's very difficult to stop. Very bad habit to get into. Depressants do the opposite of stimulants, okay? Depressants slow down the body's responses. Alcohol is a depressant. Now, it depresses a variety of things in the brain. Basically, it depresses almost all brain activity, but especially areas responsible for inhibiting risky behavior. That's why, even though alcohol is a depressant, a lot of times people will act out and they'll do things that seem very bizarre, seem very different than what they normally would do, because those areas of the brain that typically inhibit those risky behaviors, the alcohol is having an effect on those. Alcohol also increases the dopamine reception in the nucleus accumbens. So again, that's another example of how that one area of the brain of the reward center is being affected. Heroin, barbiturates, tranquilizers, those are all other types of depressants that act in certain ways in the brain. Alcohol. Alcohol tends to be one of, if not the most abused drug, especially within our culture. More than $86 billion spent annually on alcohol. Involved in most crimes, alcohol involved in over 70% of sexually related crimes. So it has to bring up the question, is it really worth it to put yourself in that kind of a situation and that kind of potential danger to yourself and others? Hallucinogens. Basically, we think of hallucinogens as being kind of psychedelic drugs because they distort perception within the brain, and so people kind of get reality mixed up. I mean, it's a very bizarre way of viewing life. LSD, mushrooms, marijuana, those are three different types of hallucinogens. Now, LSD actually stimulates the serotonin neurotransmitter, rather. It stimulates those receptors for longer amounts of time in the brain, so again, causing distortions in perception. Marijuana is kind of very complex in terms of the brain because it does a variety of things. But it also indirectly increases dopamine in the nucleus accumbens, which is why that a lot of times people tend to get kind of in the habit of using marijuana. Studies also show, a lot of studies show that marijuana is correlated with impairment in memory and in cognition. Especially, they have found this to be true with new users and with users who depend on marijuana a lot, who use it a lot. So, those are some risky things that result from marijuana. Opiates is the last category we'll look at. And opiates, including things like morphine and heroin, codeine, all of those involve relaxing the body. It's kind of a relaxation and pain control. Opiates act as an agonist. In other words, they mimic the endorphins in our own body. So endorphins are like painkillers in our body that relax us, try and deaden the pain, and basically take our mind off of whatever the cause of the pain is. Now, all of these drugs do cross the placental barrier. So, in other words, if a woman's pregnant, all of these things are going to cross and go into the placenta, which of course nourishes the fetus. So, we refer to those as teratogens. In other words, they're chemicals, harmful chemicals that can create significant damage to the fetus. So when you look at all of the potential issues and all of the problems that are associated with drugs, just remember, just say no.